Thank you very much for the warm introduction. It's a pleasure to be here too. It's a return trip to Lisbon for me, as you know. I haven't been here for a number of years, and it's a delightful city. And this has been a very good meeting too. I had the honour of addressing a very distinguished audience here, and it's been a pleasure to get to know and talk to some of you during this week for the first time. So my topic is kind of focusing on the theme of this word photoptics. I don't know if anyone actually explained where that came from during this meeting, but it's obvious to us. It's a kind of there's a word that is like a synthesis of two other words. Photon and optics, obviously, but if you look at the content of what we've been looking at during this week, most of the talks, I think, haven't really said very much actually that relates specifically to photons, and it's rather strange, because if you look at the subject of photonics as a whole, you can read whole papers about photonics and not see any mention of a photon. Well, it's true, if you read electronics papers, you don't necessarily expect to see the word electron in there. But it does reflect the fact that sometimes in optics, we can lose sight of the photonic nature of what's involved, and sometimes it's more important than you might think. But also, as we've been discovering, and many people around the world have been discovering in recent years, the nature of what the photon is actually almost less clear to us now than it was, say, 50 years ago, or 100 years ago. So my theme is partly to draw out some of the things we've been recently learning about a photon and to show how they're important in the subject of photonics and photoptics, if you like. I'll also say a little bit about photon wavefronts, which is one of the particular aspects that is kind of a theme through some of the topics which I'll talk about, but that'll come a little bit later in this talk. Okay, so what are we going to do? Oops, just going to move on. There we are. As I've said, advances in photonics bring the fundamental nature and the properties of photon under fresh scrutiny. There's things like optical vortices, which you can explain classically, but actually there's very interesting photon-based properties of those things, and I'll talk a bit about those during this lecture. In that particular connection, properties of the wavefront of a beam of light become particularly important, and also the phase structures, but as I say, down to the level of the photon itself. So, here's two sort of snapshot questions. What is a photon? What is there fundamentally new that can be learned about a photon, and how we have to develop the photon picture of light? And then can this lead to new applications? And actually, we'll see that it does. New principles, new applications in a variety of different